Hello friends, welcome to session 5 on projection of solids. In this session, we'll cover projection of prisms and also projection of cone. See, in this problem 9, a pentagonal prism of base size 25 and height 60 is hung on one of its corners of the top surface. Draw projections of this prism when the top view of the axis is inclined at 50 degrees to VP. Assume bottom surface of the prism to be nearer to the observer. Now you see here, since the problem is similar, this is left to the reader as an exercise. You see here, this is a pentagonal prism. As I told you, you start in the same way. You draw pentagon of size 25. That is A, B, C, D, E will represent the top surface. A1, B1, C1, D1, E1 will represent the bottom surface. A1, BB1, CC1, DD1, E1 are the vertical edges. And the height is 60. Then for the labeling in the front view, it is B is seen, A is not seen, B dash, A dash, C is seen, E is not seen, C dash, E dash, this is D dash and this is D1 dash. In the same way bottom, B1 dash bracket A1 dash, C1 dash bracket T1 dash and of course this is D1 dash. This is the top surface, this is the bottom surface, 5 edges here, 5 edges here, 10 edges, here 2 merging edges BB1 AA1, here 2 merging vertical edges CC1 E1 and here one vertical edge DD1. Totally 5 fly 2 2 1 totally 15 edges. Now this problem is hung on one of its corners of the top surface. Let us say I tie a thread to this corner and hang it in the space. It tilts this way. It tilts this way. And you know very well, for a symmetrical solids like this, you locate the axis first. This is perpendicular bisector of any two sides will get the axis. O dash, O dash is the axis. On axis, the center of gravity is located at half the distance. If it is 60, it is 30. In pyramids and all that, you know, G dash was located 1/4 of its height. But since it is a prism, it is located half of its height. As I told you earlier, the concept or the significance of G dash is, if you imagine a horizontal plane here at G dash, the weight below is equal to weight above. G dash is located 30 mm, that is half the total height. Okay, now if you tie a thread to this corner and hang it in the space, what you should know is D dash G dash will be perpendicular to HP, that is 90 degree, perpendicular to HP or XY line. In this way, you do this. First stage front view is same as second stage front view, and the continuation of this is left to the reader as an exercise. As you know, how you complete and all that. That is, you take all the points to the other view, join the outer boundary of these points by dark lines. Since top surface is nearer, darken the top surface and immediately remaining edges of the other surface make it dotted. And since the DD1 and all that is nearer, okay, DD1 is the nearest edge, you darken it, and BB1 and AA1 you make it dotted. In the third stage top view, what you do is the top view of the axis is inclined at 50 degrees to VP. Whatever you get the top view here, you incline it at 50 degrees to VP and get the final stage front view as I've done in the earlier problems. Now this is also a problem of hanging on prisms. A hexagonal prism of base size 45 and height 112 is hung on one of its corners of the top surface. Draw projections of this prism and top view of the axis is inclined at 50 degrees to VP. It is more or less the same thing, but previously it was pentagonal prism, now it is hexagonal prism. Now it is 45 and 112. Let us say, first you draw the hexagonal prism as usual. AA1, BB1, CC1, DD1, E1 and FF1, you name it. Okay, of size 45. And since the dimension is little big, you can take the scale 1:2. Okay. Now A, B, C, D, E, F is the top surface. A1, B1, C1, D1, E1, F1 is the bottom surface. AA1, BB1, CC1, DD1, E1, FF1 are the vertical edges. There is top surface 6 edges, bottom surface 6 edges, and 6 vertical edges will make 18 edges. In the same way, when you go to the front view 112, okay, this is 6 edges top surface, this is bottom surface 6 edges, 1 here, 2 here, 2 here and 1 here. In that way, 6 edges here, totally amounting to 18 edges. Now, since again this problem is hung on one of its corners of the top surface, you either take A dash or D dash, whichever is convenient to you. Let us say you take D dash. And first you have to locate the center of gravity. If it is 112, locate G dash at the center. That is, you when you get the center here by bisecting any two sides, okay. When you get the center here, from here you take the axis O dash O1 dash. On the axis, you locate G dash at a distance of 56 mm from the base or the top surface. Okay, G dash you locate. You may draw an imaginary line D dash G dash light 0.13 mm line. Okay. Now, when you hang this in the space, when you lift it by tying a thread to this corner D dash and hang it in the space, this is how it looks. This is how it looks. And as you know here, you are looking from the top, and the completion of this also is left to the reader as an exercise. It is done in the same way. Once it is done this way, obtain all the points in the other view, join the outer boundary of these points by dark lines. That is step number 1. Top surface is nearer. Darken the top surface. Immediately remaining edge the other surface, make it dark dotted. And whichever edges remaining, that is 6 plus 6 plus 2, 14 edges would have been over. And the remaining edges, whichever is nearer, you darken it. Whichever is far away, like AA1 and all that, make it dark dotted. In that way, you are able to complete. And in the third stage top view, same second stage top view, whatever you got here, you tilt it such that the top view of the axis is inclined at 50 degrees to AP and get the final stage front view. Please understand, since it's a problem of hanging, don't put any corner lie on XY line. This problem, as you know, it is all lifted up. Even the bottom corner A1 dash is lifted above HP. That means this solid is hanging in the space. And as per the property of the solid, the line connecting the corner, that is point of hanging, and the center of gravity will be perpendicular to XY line or HP. Okay. In that way, we are able to complete projection of prisms in all respect. Projection of prism, if you look to whatever problem I have done, okay, you can easily complete the problems what has been given in the examinations or in the MSCs or the tests or wherever it is. Okay. Now, we'll start with a problem on a cone. A cone of diameter 100 mm and height 150 has a point of its rim of the base on HP with its axis inclined at 45 degrees to HP. Draw projections of this cone when a diameter of the base is inclined at 50 degrees to VP. Assume base of the cone to be nearer to the observer. Okay. Now you see here, this cone is of diameter 100. You draw a circle of diameter 100. Since the diameter is big, you can take a scale of 1:2. That means you draw a circle of diameter 50. Okay. Now, there will be a small change in the procedure, particularly with respect to cone. Please follow that carefully. Okay. Now, see here, you have drawn a circle. And then, since there are no edges here, unlike pyramids, prisms and all that, okay, you divide the circle into 8 equal parts. Then A, B, B, C, C, D, D, E, E, F, F, G, G, H and all that and H, A, they are all imaginary edges. Okay. In that way, I have divided this circle into 8 equal parts and hence imaginary 8 edges, I have got it here. Then get the corresponding front view 150. If you have taken a scale of 1:2, 75 mm you take. Okay. This is the apex point. Okay. You just join this. Only outer boundary only you darken because these are all OA, OB, OC, OD, OE, OF, OG, OH. They are called the generators. They are imaginary generators here. Okay. The generators, don't darken it. That means this OB and OH generator, OC and OG generator, OD and OF generator, don't darken. Only the outer boundary, this OA generator and O dash, E dash, OE generator only you darken it. That is naming also. It is A dash when you are looking from here, B dash bracket H dash, C dash bracket G dash, D dash bracket F dash, and this is E dash. Okay, please understand. It is in the particularly the cone. Since these are all imaginary generators, don't darken these two, this one, these two and all that. Only the outer boundary you darken it. Okay, and only the circle you darken it here. And this O, you write O here. This entire thing, OA, OB and all that, whatever generators you assume, all should be light. Okay. Now, what is done is, now it is tilted right. When you tilt right, it is resting, it is not a corner or base on HP. You should know that this is a circular surface and this becomes, E dash becomes an imaginary point of its rim of the circumference on HP. Did you follow? It is an imaginary point of its rim. It is an imaginary point of its rim or circumference on HP. It is not a corner or edge on HP. That is, as this cone is resting on an imaginary point E on HP such that the axis is inclined at 45 degrees to HP. Okay. Now, what you should do here is, for getting the top view, we have a slightly changed procedure. Okay. Now, once you have this, you are looking from here, anyway apex nearer than the base, get all the points. On this A, on this B, on this H, on this C, and on this G, on this D, on this F, here E, and here O. Okay. Now, to complete this ellipse, you have an option in solid edge. That is, ellipse option is there. You click to the center and go here to the minor for the minor axis and extend it till G also. Automatically the ellipse is directly obtained. That means you start from O, ellipse option you take, click the center here, then go either here or here for major axis, click here and go here or here for minor axis and you get directly the ellipse. Ellipse initially you make it light, don't darken it. And now you see here, this is the point of apex. This is the point of apex. From the point of apex, draw two tangents to this ellipse dark. Tangents to this ellipse dark. Directly darken the tangents, this tangent and this tangent dark. And now since apex is nearer, the complete base cannot be seen. Now once this point of tangency is here, point of tangency here, this becomes the base curve is this becomes the inner curve, this becomes the outer curve. Okay. That being the case, since complete base cannot be seen, outer curve you darken it, inner curve make it dark dotted. Okay, outer curve make it dark, inner curve make it dark dotted. Show the all other generators by light lines. Okay, show the axis on all that. Now, as you see here, that is one of the diameters of the base is inclined at 50 degrees. You don't take EA because it is not in true length, but CG is in true length, and they say one of the diameter of the base is inclined at 50 degrees to VP. Immediately take CG only because it is in true length. You incline it at 50 degrees, copy and paste such that CG is inclined at 50 degrees to VP, and do in the same way. Then you get O dash, you get all other points and all that. First you draw the base curve light by using the R command, 3-point R command also you can complete this. Then from O dash draw two tangents dark. Okay, since base is nearer, complete inner curve as well as outer curve, make it dark. Because base is nearer to the observer. Okay, this and this are the tangents to the curve drawn. As a result, this becomes inner curve, this becomes the outer curve. Since base is nearer, both outer curve and inner curve are darkened in the view. Then show the generators as light lines and all that. And that completes the end of session 5. Thanks for watching. We'll continue with other sessions shortly.